Welcome to my channel. This is Naresh. In this session, we'll see the virtual ground concept of operational amplifier and open loop, closed loop configuration of op-amp and their application. Let us start our discussion. Virtual ground. The definition of the virtual ground is a virtual short circuit means that whatever the voltage is at 2 will automatically appear at 1 because of infinite gain. Yeah. In the op-amp, we'll consider the gain is infinite. So if we see here, this is the op-amp which is having infinite gain. So what the definition says is whatever the this will take it to whatever the voltage at node 2 will automatically appear at node 1 because of the infinite gain. Let's see the derivation for this. See, now we have op-amp which is ideal one, this is op-amp which is ideal one. Now this is ideal op-amp having infinite gain. So now what else the V0 of op-amp is? V0 is gain times here the voltage at this point to voltage at this point. So V2 times V1. This gain is open loop gain. Now if you see V0 equal to AOL times difference of, this is the difference from here to here. We'll take, this is the difference of two voltages. Now we'll take VID equal to V0 divided by AOL. So we have VID is V2 minus times AO V0 divided by infinity. This is nothing but 0. So V2 equal to V1. So from this derivation, what we can see is the voltage V2 is equal to the V1. So whatever the voltage we have taken at this is equal to this. Because of the two voltages are same, we can form the short here. So this virtual short is, what do you mean by virtual is, which is not physically present, only by voltages we are making short. That's why we call this is virtual short. And in which cases we can apply this virtual short? Mainly when the op-amp is ideal one and it should be provided to negative feedback. What does it mean is the part of output is connected to the input at non-inverting terminal of a op-amp. This is called negative feedback. The part of output we are taking to the input at non-inverting terminal of the op-amp. So it satisfies the negative feedback condition. So this is what I have mentioned here when we can apply the virtual condition. First one is the op-amp should be ideal one, means it should have, we can write this is ideal. It should have infinite open loop gain and it should be provided feedback, and the output of op-amp should be within these two saturations, means the V0 should be in between plus Vsat to minus Vsat. If all these three conditions satisfied, then only we can apply the virtual ground concept in our op-amp circuits. So next, that when we want to use the op-amp, we should provide two configurations. One is open loop configuration, second one is closed loop configuration. First one we'll see open loop op-amp. So if you see the schematic op-amp, it is nothing, it is not at all connected in any external components, means you see this is output, this is plus Vsat, this is minus Vsat. The part of output nowhere connected to the inputs. So this op-amp is in our open loop configuration. So what is the use of open loop op-amp is we can use as the comparators. What do you mean by comparator? Comparator is nothing but to compare two values at input of the op-amp. Let's take This is op amp. Here only I will explain. So here, so first op amp as a comparator is, it will compare these two voltages. Two is non-inverting and one is inverting. If V2 greater than V1, that case we will get V0 equal to V2 greater than V1. V0 is plus V saturation, or as per the diagram it is VCC or VCC. If V1 greater than V2, the voltage at inverting terminal greater than the voltage at non-inverting terminal, that case V0 output is minus V saturation, or as per the diagram it is minus VW. Means in open loop configuration, if the voltage at one terminal is compared with other terminal and the output varies according to that. So the main disadvantage of the open loop op amp is we can't control the gain. The stability we can't achieve by using the open loop op amp. So for that one, we have to provide the closed loop, either negative feedback or positive feedback, so that we can control the gain of the op amp. So next we'll see closed loop op amp. The main advantage of the closed loop op amp is that we can control the gain. It is gain we can control. So that's why we are moving to closed loop op amp. Now next question is how we can control the gain. By providing the external resistors, we can control the gain of the op amp. How we can control the gain by these two resistors, we'll see in next session. First I will tell you the advantages and disadvantages of closed loop and applications here. See, this is output. The part of output is connecting to the inverting terminal of the op amp. So this we call as the negative feedback provided for the op amp. If part of output is connected to the inverting terminal of the op amp here, so this is positive feedback. So why we came to the closed loop is to control the gain. In the controlling of the gain, we have two feedbacks. One is negative feedback, one is positive feedback. Next we'll see the applications of individual feedbacks. Negative feedback applications. Here first one is we can use this negative feedback circuit as the inverting and non-inverting amplifier and voltage follower and I2V. This is called current to voltage converters, active rectifier. This also we can achieve by using the op amp circuits, integrator and differentiator circuits. We can use the negative feedback. While come to positive feedback, we can use this op amp as a schematic trigger circuit. This we will see in detail later. And a stable multivibrator. This is square wave generator. So by providing the positive feedback to the op amp, we can use our circuit act like as a square wave generator. These are the applications and applications and advantages of the op amp over the open loop configuration. Yeah, in next session we'll cover the inverting and non-inverting op amps with open loop, gain, infinite and finite cases. Thank you for watching. Please subscribe my channel and comment for any modifications and improvements. Thank you.